Fine. So this is the plan which I've shared with you guys. So today we are going to look. So let's see like what we have done so far. First, so we planned for D3JS, a basic JavaScript which is required to understand D3JS. Then we walked through some of the examples of HTML5, CSS3, and we have also seen some D3JS fundamentals. Today we'll be focusing more on fundamentals of D3, but more in terms of scales, what are the different scales are available, and how we generate basic shapes. And we will also look into some design principles and also see some of the quick tour of char fundamental. So like what are the specifications which we require to draw the basic graph. So let's say we want to build a graph, maybe a line graph or maybe some pie chart. So how we create some standard, like how, like what is the first thing we should think about in terms of, let's say, layout, maybe margin, and maybe width and height for an SVG, and what should be the color coding, and how we can map the data to the specific requirement which we have. So we will see few basics now, more basics around the graph. And yeah, in the next session we will look into the network hierarchy and some practical examples. So the third, 2nd of March, we'll also look into some more examples around. We'll see the application of D3JS. So you can see we will have nearly like 2 sessions which will be purely dedicated to examples, and also the next session we will also look into one of the example and also see some advanced concepts around tree maps and network hierarchy. So let's start for the basics. Now everyone can see my screen, right? Okay, fine. Great. So first we look into some of the basic scale which we have in D3JS, and we will also see like how it works. And you should know these basics really well, because sometime when the data is given you in such a form and you need to transform, because the data is not uniform always. Whenever you're working with any financial data, it's not uniform, right? It's values which will be discreted. So you need to know like what kind of scale you use to map those data to the specific graph. So first we are looking into the linear. So in this example you can see we have defined a CGPA converter. So we are using D3 and we call scale linear. So what scale linear does, it takes, so in mathematics, like there is a domain and range. If you have learned calculus, like there are some specific set of domain and there is some set of ranges. So this is a one-on-one mapping which is provided by the scale linear. So what it does, it takes an array, it takes a range of values in a domain and try to map to the range of values in an output, right? So let's say we have a 10 scale CGPA system and we want to convert into 0 to 4 scale CGPA system. So how beneficial is this? First of all, like why we need to do this? You can assume there is a use case. Let's say when you want to do the comparative analysis between the results of some university in US and some university in India. So if you see in India, the CGPA system always work from like 1 to 10 CGPA, but in mostly in US the university CGPA work from 0 to 5. So what you need to do before the comparison of the India university data, you want to convert the scale, you want to convert the data to a scale so you can compare at the same ground level between, like in between both the universities data. So you, so the first requirement for you to is convert the India university data from 10 CGPA to 5 CGPA, right? So in this example what we have done is we have taken a domain which is 0 to 10 and a range from 0 to 4. So when you ask for CGPA converter, so it return of, so this d3 dot scale linear is, this is a chain of methods. So you have passed a domain and range, and that will be passed to scale linear. Now scale linear will return a function to this variable, and in this function if we pass a value 5, now this 5 value, what should be the output? So this should be like, now let's just open the browser, and if you go it in a console, you can see the output is 2. Why? Because the values, which is like 0, 1, 2, 3, 4, and 5, right? You can assume till 10. Now these values, now it is mapped to 0 to 4, right? So what should be the mid value? So if you're looking for 5, the mid value in a range is 2, right? So that will be like 0, 1, 2, 3, and 4. So this is how the mapping going to work. So the middle value will map to this. So 5 will map to 2, right? Now, can you tell me the output if, let's say, if I type uh, 11? Can anybody tell me like what should be the output now, Ganesh? Yeah, so we have given a domain 0 to 10, right? And range is 0 to 4. Now I'm asking for a value which is greater than 10. So, yeah, so what should be the output in that case? Do you think it should be like more than 4, or it should be an error? Okay, okay, okay. So you understood the scale linear, how it works? Yes. So what it does, it takes a domain of values, right, and convert into the range of values. So it convert like one-on-one mapping. So that is like a one-on-one like discrete. It takes the input as a discrete values and convert into discrete output. So there is a one-on-one mapping. So if you see 0 to 10, right, it is mapped to 0 to 4 range. So when you search for 1, right, there should be output. When you search for 2, it should be there should be some output in the range 0 to 4. So when I search for 5, which is the middle value in this domain, now my output was 2, right? So let's say if it is 5, now you can see the output is 2, right? Now if I let's say if I search for 0, my output is 0. If I search for 1, my output is 0.4, because it tried to convert the value in this range. So if I search for a value which is greater than the domain, what should be the output? Can you guess? Okay, so you can see it converted 4.4. So in D3JS, see why it doesn't throw error, because see that's why we have to be very sure when we use these kind of functions, because D3JS should not try to, because D3JS is a library which will not throw error for this case, because otherwise your program execution will stop in between, right? So what it does is just convert. So it gives you privilege to use different functions, so you can clamp those values. Let's say you don't want the output should be uh, beyond than 4, right? Because it's 4.4, right? And you expected the behavior should be 0 to 4. So that's why what D3JS people have done, they have created a function called clamp. So you can clamp, you can set to true. Now I'm passing value to 12. Now you will not have unexpected behavior, because your graph has not handled those values. So now if you refresh this, you can see you got a 4. So clamp is used when you want to bound the value, right? So and linear is used for one-on-one mapping. So make sure whenever you use linear and you don't want any unexpected behavior in the range, because if you're not able to map those values in a graph, then you will have an issue in the x-axis and y-axis mapping. So that's why you should use clamp. Okay, so yeah, so this is a simple method. You just add dot clamp to true, then whatever the values you have, it will it will not go beyond the range of the max value of the range. So this is our clamp method, and this is our linear method. Now next we can see a log method. So log method is also a similar kind of it works in similar fashion, but only thing is instead of mapping to linear, it will map logarithmically. So if you see, we can use a method called scale log. You can give a range of values. So we have given a range of values this, and the domain should be this. So whenever you pass any value inside this, right, the range will be mapped to this. And we have added a base to 2. Now if you apply, so this is a method called b step. If you pass a value of 1 lakh and you try to, when you get the output, it will return log base of that value which is mapped to the range, right? So let me just show you this. So you can see output is 17, which is between 0 to 20. So what it is, it's a log scale. Previously it was a linear scale. And now this is now if you want to understand the example practically, what you can assume a situation. Let's say you have numbers from 1 to 1,48,576, and you are applying a binary search, and you are searching 1 lakh number. You are searching not 1 lakh numbers. You are searching for 1 lakh number, uh, right, in a domain of these numbers. So how many steps it will take for a binary search algorithm to find you or to search the position of this number is 17. You understand this example? Asta, Rupali? Okay. Yes, sure, sure. So, so you have a method. You created a B step. This is like the binary step. So what scale log does, you understand this part. So basically it takes the input these many values and it produce the output within this range. We have added a base because we are doing some log scaling. Now when we do the base of 2, that is like a like right, the search complexity in binary for binary search in an array is log base of 2n, right? Now in this method, in B step, we are searching for 1 lakh digit, 1 lakh number, and you have a range of numbers this, right? And the output is 17. So how many steps the binary search took to find this number in an array? Because this is an array. This is not two numbers. This is a range of values. So in this domain, to search this number, it takes 17 steps for a binary search to find the position of this element in an array. Understood this? Yeah, Ganesh. Yes. Mm-hmm. Yes. Yes. Because the log of base 2 of this will not go beyond 20. Yeah. So that's why we have set the outbound as 20. Okay. So everybody understood the log scale. See, why you should relate these like this scale system to a specific algorithm, because this is a use case, right? So you may need to know like when you need to see the CGPA converter example was really straightforward, but you need to analyze what kind of situations you need to do the logs, the linear scale, right? So when you want to convert, when you want to compare like two values in a graph, but one set of values are following the specific range of outcomes, and you want to do, when you want to do the comparison, it should be the same set of range. So to get the same sort of range, you can use linear scale. But when you want to do kind of a log scaling, right? So you need to see the situation. So base 2 will help you to identify, like, you have a set of, let's say, inputs, and you have to do the base 2, because in binary search you actually look for half numbers, at first. You look in to the left, you compare with the middle element, then you choose either the left or the right, right? So that's why we have taken a binary example as a use case, but slowly, like every scale, you try to see what kind of situations it will be helpful to apply. So this is log. Now the third one is we have seen clamp. Let's say scale quantize. So scale quantize, you have to give, so this is takes input as discrete but output is non-discrete values. So you can see a range of uh, you can say a range of strings, or it can be like anything, but it's a non-discrete values, and the domain is 0 to 100. So when you say q scale for the 5, what should be the output? Can you guess? It's just a mapping, right? So it does the mapping based on like 0 to 100. The values will be assigned, so range of values will be assigned to this, a range of value will be assigned to this, from the domain. So if we search for 5, what will be the output? Can you guess? Asta? Yeah, Ganesh. Yes. Yeah. Yeah. Yes. Yeah. So you have a scale quantize. You're given a set of domain, and you are mapping these discrete value to non-discrete values. Now you are passing a range to it. Now scale quantized internally has to do something. Okay. So before telling you guys like what it does, I want you to predict what it can done. What it should do in terms of mapping those non-discrete values to the domain value. Mm-hmm. Okay. Okay, so what should be the mapping? So when you search for 5, what should be the output? Okay. Okay, what do you think, Asta? Mm-hmm. Yeah. Yes. Mm-hmm. Okay. So this is Rupali, right? So Rupali, yeah. So Rupali, you are correct in a lot of sense. So what it does, it map 0 to 19 values will map to neon caret. So when you're searching for 5, the 5 will fall into 0 to 19. So the output should be neon caret, right? So if you see, output will be neon caret. So when I search for 20, you can say it's still neon caret, but when I go beyond 20, oh, just a minute. Okay, so it should not be like this. A range, yeah, it should be like a range of value should be mapped to a specific string. So when I search for 14, 40, it's a Caribbean, because yeah, so because 20 is from 25, it should take the Caribbean, because 0 to 24 should map to neon caret. Now you can say Caribbean. Yes. So whenever you, so this input is always domain. So and domain map to your range. Now here, it is like you can say implicit mapping happens with the help of scale quantized. So when you search for 24, it should be neon caret, because 0 to 24 map to neon caret, then 25 to 49 map to Caribbean green, and then 50 to 74 will map to this, and then 75 to the last one will map to iris blue. So it's just like one fourth of values should map to the first one and the remaining henceforth. So this is an example of scale context. Okay, so you need to know. So there are very few basic scale system in D3Js. We have seen linear, we have seen log, and this is scale context. And then you have something called the scale ordinal, and this is very straightforward. So you have a set of non-discrete values you are mapping to discrete value, and scale context is mapping of discrete value to non-discrete value. So here is opposite of it, scale ordinal. So you have a map to 10. So let's say, let me, can anybody guess the output of this? What should be the output of line number 12? Ganesh? So what do you think this scale ordinal will do? So, so, so there's a non-discrete. Yes, yes. Yeah, tell me. Okay, okay. What about the next one? So next one is B. You said 8. Okay. Yes. And yeah, so output should be correct. So you let's see this. You can see 10 and 8, right? So this is a non-discrete value to discrete value, and then you have something called unknown. So let's say when you're searching for a grade, or you're searching for a domain value which does not exist in the given domain, then it should display this exception, which is like not a grade. So when you search for y, which is not mapped to this grade converter, then it will throw an error, not a grade. So it's not an error, it's just like handler. So it says not a grade. So this is your scale ordinal. So there is a linear, log, then scale quantized, and scale ordinal. So these are the basics one. Then there are two more basic, which is one more called invert extend. So as you have seen this example scale quantized, where the domain, a range of domain mapped to a specific value inside your range. Now when you want to see, so when you want to see what kind of values, what kind of range is mapped to this, right? So you can use invert extend. So let's see this. Now you can see here 0 to 25 is mapped to your human carrot. When you search for Caribbean, 25 to 50 is mapped to Caribbean. So invert extend will just give you the range of values which is mapped. So yeah, anybody has doubt so far? Jo, ask. Yeah, yeah, Ganesh. Fine, 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 no problem. So in invert extent, what it does, it try to find the range of values. So we have seen the scale quantized. What it does, it map a range of values to a specific value in a range, right? So now neon caret is mapped to 0 to 25, right? Right. So that is the range. Now invert extend will give you the range of values. So range of value, what range was assigned to neon caret? So when we, right? So that's the invert extend. Okay. And anybody has doubt? Astha Jyoti. Sorry, not Astha Rupali. Do you have any doubt so far? Okay, cool. So the last one which we have is scale band. A scale band. So let's say you have given a domain x and y and z, right? And we have a 0 to 300. So when we look for x and y, x and z, there is a output. Can you guess what should be the output? Anybody? Astha, can you guess what should be the output of this for the scale band? Mm-hmm. Okay, fine. Let's see. So you can see the values for x is 0 and value for your z is 200, right? So what it does, it map. So instead of mapping the range, because for the range, instead of mapping a range, it maps a specific value 0. So it takes the so if you see here like x, let me print y as well, and let's consider this. Now you can see 0, 100, and this. So what scale band does, it actually look what kind of bandwidth it can use, what kind of, not a bandwidth, so it what kind of number it can use. So instead of assigning from 0, it start from 100. So 0, 100, 200, right? So if you pass any other value, let's say maybe a, and let's try to console that value. So you can see now it becomes 0, 75, and 115 to 25, right? So why is that so? So because this is a range 1 by, like 300 is the maximum value, and you have the four values to assign. So it assigned the first value to 0, right? The second value to 75, and third value to 150 and 225. So it doesn't care about the last one, but what it does, it takes this value like 1 by 4 and try to assign the equal number of, or you can say it try to assign the equal bandwidth of all the values in a range, and it will start from 0. So 0 is mapped to x, 75 is mapped to this, then 150 is mapped to this, and after that 225 is mapped to a. So is that clear? And otherwise you can see the output of bandwidth. So let's see this now. Yeah, yes, we are recording this. Yeah, yeah. So now you can see the bandwidth was 100, right? So you can see bandwidth. So this bandwidth, so how they take the bandwidth, so if they say okay, the maximum value is 300, so and we have three values, so what is the maximum bandwidth we can assign? So it takes like 100, 100, 100 is the fine one. So it's starting from 0 map to x, then y map to 100, and z map to 200, right? So nobody is mapped to 300, words always start from 0 inclusive. So this is the example of a bandwidth. So you try to understand first this, and based on that you can easily understood this. Is that clear? Ganesh, Rup- Rupali, Astha. So this is all, yeah. So this is all the basics, basic in terms of scale, which you need to know. So always remember there's a linear, log, clamp. So clamp is just to bound the value for a range. Then scale quantized, uh, then scale ordinal. So you need to know like when you need to map from discrete to non-discrete values, which one to use when you want to find a range of values associated to a specific range, or maybe a specific value in a range. Then you use invert extent. And scale band is also like when you want to assign a specific value from a range to input, right? So you'll do scale band. So just know these seven things as your basic uh, in terms of scaling in D3JS. So you will not face, like you will not see any other functionality like anybody will be using maybe an advanced graph as well. So this is the first one. Now we'll have some more examples. Now we will see uh, some of the basic fundamental, like in drawing the graph. We have already seen some D3J's fundamental in, and also cover some like SVG. Now you understand like how to draw SVG, and you have some basic fundamental knowledge of SVGs. But what we should consider before designing a graph, that is something is really important. So for that we are going to cover some design principles. So first of all, the first design principle when we are drawing D3J's graph is a 5-second rule. So what 5-second rule says? It says uh, when you when you have a problem, right? So you should be able to uh, like pictorially understand, like, or not pictorially, but anybody, like when you present them a graph, right? They should not take more than 5 seconds to understand what use case this graph is solving. If it takes more than 5 seconds, then definitely something is wrong with your graph decision. So let's say when you have a bunch of students in a class, right, and you want to assign a number of students who fall into a specific range of marks, and you draw a pie chart, anybody see that they can understand it's a distribution of marks in a class. So if they take more than 5 seconds to understand, then it then makes sense like something is wrong with the design of graph. And yeah, so we might need to think about different graph for that problem. The second is a selection of a right chart. So the selection of a right chart is very important in terms of data visualization, because sometimes not always line chart will make sense. So every chart has some semantic meaning. So let's say when you have a line chart, it mostly display trend. And what is the meaning of trend? When you have a sort of data and you want to plot how the data varies over a specific period of time, then it makes sense to use line charts. So then, considering bar charts, so bar chart is always used to compare the different groups over time. Let's say there is two countries, let's say India and US, and we are comparing the economy every year for both the countries. Then it makes sense to use bar charts. Similarly, the next is pie chart. So pie chart is used to show the distribution of data in terms of like percentages. Because why it because then when you have upper bound set, right? So in, let's say when when we are showing some distribution for a marks, then we have an upper bound which is like 100, let's say the maximum marks of a subject, right? So there is upper bound set. So when there is upper bound set and you want to show the distribution, then it makes sense to use the pie chart. Then the scattered chart. Scattered charts are used to show the relationship between data. So when you have specific data points and you want to show the relationship, let's say there is a weather. Now inside weather, there is a different. Let's say there is a temperature, there is a humidity, there is a precipitation. So there are different factors, which is actually contributing to the weather report, right? So in that sense, it makes sense to use the scattered chart. Then the last one is a tree map, which is used to display the hierarchical data. So that's all is required. So this is like the basic fundamentals. So uh, we will cover line chart and pie charts today, and also see some basic examples how to draw these charts from scratch and understand each and every line of code, which should be which is really important for you to know. So when you see the complex graph, you can easily relate those syntaxes really well. So making sure like these are the fundamentals. So whenever you have to draw a graph, you might need to maybe bring more interactivity to this chart. You might need to uh, make it more fancy and more usability for a user to understand the graph and plot as much as information. So you need maximum these many things. There are ways to actually, so if you see your bar charts, you can also do apply some fancy css and animation to make your bar chart looks not even the traditional one. You can actually make it look really modern. So there are different ways you can actually extend your graph in terms of look and feel and in terms of usability, but these are the fundamentals. You will build everything on these top of it. So this is the chart selection. So when you have hierarchy, you use tree map. When there's a comparison, you can use line and bar chart. When you have a composition, you use pie chart. When there's a relationship, you use scatter chart. So this is, you need to know like what kind of graph you need to choose based on the data as well as your use case problem. So let's think about if you have some, let's say you have financial data, right, and you want to plot some stock value over the period of time for a specific, let's say Google stock, how it is doing in the last 1 year, or maybe how is gold is doing from the last 1 year, then you can show, and you want to compare this between uh, like with the different stocks, so you can use line chart, you can also use bar chart. So depending upon what is best suits for that problem, you can use line over bar or bar over line. So can anybody tell me like when do you think we should use line chart, compare, like when there's a comparison and not bar chart? Do you have any situation in mind? Mm-hmm. 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 Okay. Yeah. So the line chart basically is when you have a continuous data, when you have a continuous change in the data, and that you want to compare. And bar chart is not the continuous; it's a non-discrete one. So discrete will go for the line chart, and non-discrete will go to bar chart. Similarly, hierarchy. Can you tell me an example for like when you want to compare the hierarchical data? Mm-hmm. 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 Yeah. Yeah. Okay. Any other example, Asta? Some more examples. Mm-hmm. Mm-hmm. Yeah. Yep. Yeah, makes sense. Yeah, so basically, when you have some hierarchical relationship, let's say you have a version, let's say Apple iPhone, like version 4, then it came like i5, then it came like A7 plus, and then 10 and 12. So when there's a hierarchical relationship between the data endpoints, then it makes sense to use hierarchical or a tree map in D3Js. Any example for relationship, Jyoti? Sorry, Rupali, do you think any example for scatter chart or use case of scatter chart? Yeah. So any. Mm-hmm. Mm-hmm. Okay. Yeah. So distribution. Yeah. Yes, yes, yes. So let's say if you want to see like how many COVID uh, patients are there like across the globe in different part of the region, then we can use scatter chart as an application. Okay, I think so. Pie chart we are all familiar. Like when there's a distribution, right, with some upper bound value, so we can draw the pie chart. So this is like the second principle is the selection of chart, and third, okay, not this is not the second, but this is the third one. So is a color selection. So color is pretty plays very important role, and I have already shared you some of the UI palettes with you, so you can use that modern colors. And then the general rule is we should not use more than 6 to 7 colors, because it's very hard to then it makes more complication for a user to understand, uh, or to for a user to map those colors with a specific data endpoints. Always use less than that, and don't use red color for positive, or maybe like dark colors for the positive values. Always use green for positive and red and orange for negative. So don't interchange these colors. And then uh, there should be sufficient contrast between two colors. So if you have a green and light green color in the same layer, that will create a confusion for the user to understand the graph. So make sure we should not have these kind of three different things which we need to take care in terms of colors when we're drawing the graph. So this is the design principles. So let's start with, so the first is, let's say we want to plot x-axis. Now I want you to understand each and every line of code in all the examples. So when we want to, so let's see the output first. So this is, so when you see this, right, so we have a kind of a box, right? So maybe this is an SVG with some height and width. Then we have drawn some line which has some range of values, right? And we have some, here we can say we have some margin left, and we have some margin from the top. So that's why we have push it here. And we have also, otherwise you can assume like we have axis which we have scale, translate x to this distance and translate y to this distance, right? So this is the x-axis. Now let's see in code. So we have an SVG d3 dot select body. Now we have append the SVG. We have given a height and width and the border and transform, and we have transform it to by translating 500 this. So what does it mean? So you have a SVG, like if I don't give the transform translate, so this is translate x value, y value is 0. That means when we have SVG here, it actually translate by 500, right? So we are not translating by y. Let's say if I give some 100, then you can see it goes down. So let's make it 0. So this is, you can see it translate x by 500 and y is 0. Now let's see other data, let's see like what we are trying to do with this. So we have a data is an array of values. We have x and y. Now this is something called x scale. We have defined a variable which we will use to draw the x axis line. Now d3 dot scale linear. So what scale linear does, it takes a domain that is a range of values, right? So now you need to understand this piece of code. So d3 dot extend. So extend method is a inbuilt method of d3.js. What it does, it actually, first you should know what it returns. So it returns the minimum value to maximum value. It returns a range of value. So min to max, we have passed the data. So we have passed the data, and we have passed, and we have said use the x values. So d should be d to d dot x. That means it should create a range of values from 0, 10, 50, 80, 100. So it will return the minimum value as 0 and the maximum value as 100. So and that range of values will be mapped to this 0 to 300, right? So this is the domain. Now if you see, we have 0 to 100. So these are the values, x-axis values, which is the domain, right? So there is no use of range right now because we are not using it right now, but it might be we will use when we draw some advanced graphs, right? So but right now you just need to know the scale linear, because scale linear we have to pass domain and range. So it always map from a discrete value to a discrete value, to a range. So an extent will return the minimum and maximum value for a range. And on what basis it will return? It will return on the basis of this. Let's say if I pass d dot y, you can see it returned from 0 to 400. So because you have the maximum value 400, right? So extend will take the extend method will return the range of value min and max. Then what we have done is here we have append svg and we have append a group element. So we will use a lot this group element because as we have seen in the previous classes, that group element is used when we want to make sure like different properties we want to alter at once. So it's good to use svg and then add a g element, and then we have a call. So what does call method does? Call method will actually plot the axis. So it plot, we are saying axis bottom, so it will draw the axis bottom with the range of value which will be given from a axis scale. Because when we draw the axis bottom, we need to pass the axis scale, and then we are saying transform that to 20 and 220, right? So what is the meaning of that? So this is you are translating the x-axis by 20. So that means this one is 20. You can see the red line because the SVG is the frame of reference for x-axis. So you are translating x by 20 and 220 from y. So y is here. So this is 220. So hence we are plotting this x-axis. Anybody has any doubt in this? Any line of code? Then okay. Anybody else? Sure, sure. So we are drawing x-axis with the help of D3JS. So first of all, what we've done, we have actually made a SVG. We select the body, we append SVG, and then we have given attribute height and width. We have given a border, so you can see there is a red border, right? And then we have transformed. So we have seen 500 by 0, right? That means it will move 500 to translate x by here, and we have given a y as 0, right? So y is 0. So it's here, it is 0. So that's why this is 500 and this is 0. And then you can see we have a border 1 pixel. So this is just to draw the outer layout. Now we want to draw this x-axis. So we have a data, and now how we want to so you know the scale linear will map discrete value to a discrete value as output. So we are using something called d3.extent. So it returns a range of value, not range of value, only the range. So it will have only two value, like the first and the last. So what will be the first value is the minimum one, and maximum will be the maximum of what we are looking at here. So we are saying the data point, so d is data point should be d dot x. That means in this dictionary it should be like x. So it will take the value as 100. So if I change this, so you can see it's like 0, 10, this to 100. But if I say instead of x to y, the maximum value is 400, then the range will change to 400, and it will be to distribute by 50. So that's how it will produce the output. So 0, 10, 20, 30, this, right? And now, and if we just make it y, then it will go up to 400. So basically, and then we have a range to this. Let's change this to 200. Anything will happen? You can see nothing happens, but it scale down, right? So the scale down the range, right? It will shrink the x-axis. So the mapping should be uniformly. When we have 0 to 100, so it takes the values from 0 to 100. So there is no use case of range right now, but it will be there when you want to draw the y-axis, then you can see how we can use this axis scale. So we will see the further example, but right now this is used to draw the axis scale, and then we pass this axis scale here in axis bottom, and we join this to the SVG, or maybe you can say to plot the axis. To plot the axis onto your SVG, we need a function called call. So what call method does, it will join the x-axis with the with to the SVG, and then we say transform translate x by 20. Then this x-axis will actually translate 20 from x-axis and 220 from here y-axis. So that's why it is shifted here. So it goes here by 220 and it goes here by 20. So that is why it looks in the middle. So you can see we are plotting this entire x-axis uh, with some different width and height. We are actually passing, we are actually transforming it to place to a specific position. In the later section, we will see like how we can use our margin really well, so we don't need to do a transform a lot, transform and translate. Okay, so do you understand Astha this one, x-axis? Any doubt here in any syntax like extend or call or axis bottom? Rupali? Okay, perfect. Now, okay, Ganesh. So everybody, like you all are familiar with x-axis. Let's see y-axis. It's a very similar kind of code, right? So only thing is I have given a range from 250 to 0 here in the range. So why? Because we want to start. Let me copy this and show you. So we want to start from 0, right? And we're going, so this is a range of values on x-axis, right? Let me, so so everything is same, only thing is ins yes, so instead of like x-axis we have seen y-axis, and we are using axis left because we are placing the axis on the left instead of bottom. So that's why we use axis left. And the y scale is same y scale, but we're using y value. And this is your transform translate, it's 50 to 10. So if you see, we have 50 here and 10 from top. So that's the only difference. So there is no major difference, only thing is axis left, and then you have a domain you changed, and yeah, and that's it. And then there is a translation x and y is different compared to y x-axis. So this is an example of y-axis. Okay, so now let's see how you can draw labels to a chart. So now you know how to draw x-axis and y-axis. Now we want to draw some labels, let's say stock values or a day. So how we can do that? So okay, before seeing the code, let's just think about it. So we have an SVG here. You can see SVG has some width and height, and also SVG has some border color, and we have transform by x and y is 0, and then what we have done, we have x-axis and then we have a y-axis. So we have plot the axis left this and axis bottom this, and we created x scale and y scale with the help of values. Then we have added some text, which we have, again we have translate. You can see we have transform to 90-degree, and also we have translate, and similarly here we have just translate. So we have not transform by an angle, so only just we have pushed, but this is by some minus 90-degree we have transformed. So I think that is what we have done. So let's see an example. So you can see we have a SVG. So we have SVG, we have height and width, we have a border, we have transform. So this code is very similar like what we have done before, and this is our data. So we have a day, we have stock value. Now we created a x scale. So d3.extend data d.day, and the range we have given 0 to 500. So we are expecting this value, and then 400 to 0 we have given for y scale. And if you just understand like this, so this piece of code, this piece of code is just joining the x-axis to the svg and y-axis to the svg. So x is left and x is right, and we have done some transform x and y. So this is the code for adding label called text. So what is a text? We are saying day, and then we want to transform, we want to translate by x390. So from here, this is 390, and then we have a 470. So this is 470. If you want to see in action, let's say if I make it 0, you can see the day is gone because no more in svg. But let's reduce this to 400. You can see it's going up because y is this, right? So let's say if I make 10, it will go further more up, right? So 470 is the right one. So you can see what is the problem in this. Can anybody tell me what's the problem in this code? So anybody? Rupali, can you think like what is the issue like in this code base? Hello? Can you think about a problem in this code? Okay, just take time. Maybe I need to receive one call for just 2 minutes. Meantime, I'll just mute myself and you can just look into this code. Yeah, anybody? Rupali? Okay, so I'll just tell you. So what is happening in this code base? We are to place a text on this graph. We need to use this transform, right? We need to use translate by x and y, which is very error prone or which is very manual, right? So that's why we will, in further examples, you will see instead of doing this, we will try to use some margin. So we can place our svg in a proper position on a page instead of using a lot of this. So let me show you margin example. So this is the standard. Let me just open this example for you. So you can see it's a similar example, but instead of using a lot more manual code like some manual values, what we have done is we have created a margin, a dictionary where we have top, right, bottom and left defined, right? And what should be the width? So this width of svg will be subtracting the margin left and right, right? Because uh, width should exclude this and then height should exclude this. So we have set the standard for width and height. Now if you see here, we have set this width here, right, which is the width of svg elements, and then here in this so this is simple one, like you create axis and y axis, and then this code is also simple one where you just append the x-axis to bottom. But now you can see we have a standard values. We are not using so many random manual values. So what we say, the chart, the svg, we want to place at this position where margin dot left and margin dot top. So what does it mean? So margin left will be 20 and this is 60, right? So top will be 20 and here this is will be 60. So you can see here how we are placing your SVG, right? And then we have given a width and height, which is very standard. And then similarly for when we placing the x-axis, we want to transform it to a position, right? So now with respect to the SVG, we want to transform it to 0 and then height. So this y will be the height of SVG. So you can see we are transform, this is the height. So your x-axis, which is the bottom axis, will actually transform x by 0 and y by the height, right? And height we have defined it here, which is 400 minus margin top margin bottom, right? So this is the standard way of when you're creating a graph. So instead of maybe manually calculating the values, you can use this. So you can set the default margin for top, right, bottom, left, and set the width. So this width you are going to use for your graph, right? So when we do SVG, when you use your SVG, you include this inside the graph. So this is your width, this is your width, and this is your height. You are including the top and right. So because this top, right, bottom, left will only be used for your inside graph, not for the SVG, right? So that's why we have used width plus margin right and left. But when we use the graph, right, so when we use this, we can use the direct values from your margin object. So it's just like instead of, if you see the previous code, which is your labels, right? So in this is very manual, right? And uh, so there are lot more values inside your error, inside your code, right? I think Asta has lost connection, right? She's just okay, fine. So basically the issue with this code is you have so many manual values, which is not good, which is not good for the code readability. So you can create a margin object, and this margin object you can use to set the transform x values and transform y values for your, yes, to make it more readable and more scalable code. And let's say if you want to change the value, let's say you make it 600 this, right? And then you refresh this, you can see a graph scales. So you don't need to change like all the other values because you have set the standards. Otherwise what will happen, if you want to increase the width and height, you again need to place your this x-axis and y-axis to a specific position, which will be very manual. So that's why it's very important for your code readability. And you're also, when you make changes to your graph in terms of height and width, you don't need to make changes at all the places, right? So that's why you need the standard. Is it clear? Okay, and I will share you this code base. You can try to just maybe interact with this, make some changes and see how it works. So you will get used to it and try to set a standard for yourself. So perfect. So the next is path. This we have seen, but I want you to go through it again. So let's say this is an SVG and we want to draw this graph. This is a more of path. So what happening here, this is an SVG which has some border, right? So you can see border, we have given solid 8 pixel, we have given a height and width, and we have given a svg.append path, right? And here we have translate x by 220, so we have moved this to 220, and then we have append a path and given an attribute as direction, which is m, means like you start from 10 comma 10, which is like 10 here and 10 here. So this is 10 comma 10. Next it says L to 200 to 200, that means go to the coordinate which is 200 to 200. So this is 200 and this is 200. Similarly, go to next one, which is 300 comma 20. So 300 and 20, right? So it similarly for the
Sort of worked out. I mean, what is this D in that?
direction. This is direction.
D is direction.
Yeah.
Okay.
So you
And
say,
M is
so M is a starting point. It's M is stand for move, and L stand for line.
okay.
Okay, so you draw a line from 10 comma 10 point to 200 comma 200, x and y coordinate.
Sure.
Okay, and then you just fill it with the blue, and you can also set the stroke width. Okay, so this is all about the path. So you can see like how you can draw the path. Now, why you need to know path? Because in future we will draw a line graph, right? So we will be using path.
So, I have a doubt, Saurabh.
Yeah,
So
Ganesh.
here you are giving a direction, you're saying x1 equals to
Mm-hmm.
200, 200.
Mm-hmm.
This all happens, right? I mean,
Yes,
but
yes,
to directly take
yes.
data according to data itself it needs to be line, right?
Yes, it is. So that's why, right? So path is an SVG attribute. Like this is an D3JS or SVG attribute which will take internally this data point. So when you draw the line chart, right? So line chart, you will have an API called D3.line, right? So that API internally uses path to draw, to map the values. So so this is like a more of low level, not even low. You can say uh, maybe just a low level implementation details how line chart works. Now,
Okay.
right, so this is our path. Next is line. Let's see this example as well. So this is also simpler the line example, but what we have used here, we have used an API which is d3 is given. Okay, so d3 dot line. So in this line we are creating a generator, which is we are taking x and y values, and we are passing a function which take d dot x, that means these x values and y values. Now here you can see we are using path and the datum, because we have only one set of domain data, right? Because we are drawing only one line, so we are using
Yeah.
datum, and we are passing data to it, and we are passing generator here. So you can see like the manual, the you have seen that this m, right, m and l, and the coordinate values which we have used is actually generate by now this generator, and this generator will be written from d3.line API. Okay, so this is what your how your like you draw a line graph with the help of your d3js line API.
Okay.
Okay, any doubt, Rupali? To- okay, okay, fine, no problem. So maybe I think we'll just take one or more example, because it's really important for Asta to be in call as well, because now we are going to slowly work on advanced
Yes,
concepts.
yes. I think, yeah. Even Raj is not able to join. I think both of them are still working.
Otherwise, let's do one thing. Maybe because we have to cover line chart, arc, and angle generator. These three are really important. We can wrap this session today, and maybe next Friday we can cover these three, and then what we have planned in the next schedule, hierarchy and practical example.
Sure, Gaurav. I can definitely do that.
Yeah. Okay then, guys. Then see you then on next Friday.
Sure. Thank you.
Okay. Bye bye. Bye bye.
Bye. Bye.
Bye.